New for 2012 in Motion is the support for sensors and simulation parameters. Sensors can provide a lot of valuable information. They can automatically alert us if motor torque exceeds a certain value or if joint loads are exceeding bearing limits. But we can also use sensors and motion to refine our design very efficiently. Let's take a look at this medical examination couch, where we need a certain range of travel, but at the same time we want to minimize the actuator size needed to raise and lower the bed. In the motion study, we have results to monitor the height as well as the actuator force. Creating sensors is really straightforward. From any result in motion, you can just check the option to create a sensor and choose what it's going to monitor. There is even an additional option to select just a specific time in the motion study. In our design study, we have selected geometry dimensions to vary for the length and height of the scissor mechanism, as well as the mounting position of the actuator. We can use the sensors to track if the design scenario meets our height requirements and also optimize the design to minimize the actuator force. It only takes a couple of minutes to solve, and then we can readily review any design iterations. Green is our optimal solution, and red are iterations that don't meet our requirements. One of the great features when using motion in design studies is being able to review the mechanism movement for any of the iterations that have been run. This provides great insight into the mechanism performance and aids in selection of the best design configuration. We can also go to the motion study and see the motion results in more detail for the current iteration. So motion support for sensors makes optimizing mechanism layout incredibly quick and simple. Let's take a more in-depth look at design studies using a simple example, shooting a basketball through a hoop. Now for a given launch angle, it would be great to know at exactly what speed we need to release the ball. And we could use a manual trial and error approach to find the speed, but why not let the computer solve it for us? This is where design studies really take the effort out of analysis. In this model, we want to minimize the distance to get the ball as close to the center of the hoop as possible. So we measure the distance from the center of the ball to the center of the hoop. If you have Simulation Professional, you can directly optimize the solution as we saw with the medical couch. If you just have SolidWorks Premium, then we can run a range of values and then manually pick which one best meets our needs, which we're going to do here. It's easy to incorporate motion characteristics into design study parameters as well. We just pick the entity from the particular motion study and we're provided with the properties to control for that object. In this instance, we're controlling the initial velocity and want to start with a value of 6 meters per second. In the study variables, we specify the velocity range to evaluate, in this case from 6 up to 8 meters a second at 0.25 intervals. Since the ball is smaller than the hoop, we need to account for that possible gap between the ball and the center of the ring. So solutions where the distance is less than 111 millimeters are acceptable. We click on Run, and very quickly we can see which speeds meet our goals. As we saw with the medical couch, we can click on any of the iterations and review the motion. Going to a side view clearly shows the path the ball takes. As the ball speed increases, we finally find a valid solution at 7.25 meters a second. If we were to optimize the solution, it would find the exact speed at which a solution gives us closest to zero distance. We can also go back to our motion study at any time and take advantage of the additional review capabilities, like trace curves. Now for those basketball fanatics out there, you're probably saying there's a better chance of rebounding the ball off the backboard into the hoop. Well, we can check that as well. We just create a duplicate study and add contact between the ball and the other objects. For the design study, it's an identical approach, but you'll notice that we narrow down the search to only between 7 and 8 meters a second based on the first run results. And you also notice that it's linked to the new motion study. When we go to the results, again we have great visualization. On the first iteration, the ball just clips the ring and doesn't go in. As we increase ball speed, we find several valid solutions, however. There are now 2 successful iterations where the ball goes straight into the ring. The next iteration fails with the ball bouncing off the back of the ring, which is something I do most of the time. And then a further 2 successful baskets when the ball rebounds off the backboard. With little effort, designs can be quickly improved with the sensor and design study support in motion.